No, I knew that I would get your attention with the pie chest, but no, these are just hypotheticals.
Oh,
Our treats, our treats are for tomorrow.
But speaking of which, everybody bring in sprinkles.
Yeah, sprinkle party tomorrow, so bring in sprinkles. Which, by the way, I did want to ask: does anybody have any food allergies?
Shrimp.
Okay, nobody brings sprinkle-covered shrimp. Okay, I know 2 of you really had your heart set on that, so I apologize. No sprinkle shrimp.
What?
No, but
is this a plot to assassinate me? Sprinkled covered shrimp.
Can we bring sprinkles that have no shrimp in them but are shaped like shrimp?
Okay, that would be. That is really cute though. Like I'm imagining like little lobster.
Like I've seen like they like
little
shape them like stars, like hearts, like for different
Frogs.
seasons they have like snowflakes and stuff.
Yes, yeah.
So if you happen across some shrimp-shaped sprinkles,
I will
that is a
suspect
tongue
you
twister.
squish.
That is a tongue twister. So this is just a hypothetical.
Shrimp-shaped sprinkles.
And so we're talking about 2 different kinds of races here. So if I said, okay, everybody, first 3 people to get to the pie chest get a $10 gift card. And the second one is, okay, the first person to get to the pie chest gets a $15 gift card.
Get hit by a car if we did that.
I think I would not be first because I'm not athletic at all.
I'm gonna be first.
So fortunately, this is
I don't know
If it was biking, I've
I've
got
seen-
stamina for days.
So I'm seeing some people who are like, I'm a contender, and others who are like,
I get hit by a car because I forget look where I'm going.
I'm pretty good
and I
at
just keep
puzzles.
trying to find it, and then
Yeah, no.
well, you know who has
So-
the first to the door advantage?
Oh yeah, no, that's
Empty chair. Empty chair gets the $10 gift card.
Yeah, here you go. But so these are very similar. My question to you is, when we think about all the possible ways, so assuming that there are no traffic accidents and assuming that everybody tries and that in theory everybody's got a chance.
We shall play good.
yeah, I don't know about that. That's
Okay, so this is why this is a hypothetical, but these are our baseline assumptions. Which of these 2 races has a longer list of all possible winners? So these are, we're just talking about the people in this classroom right now, so it's not like there's like a bunch of different sets of people, and we're just talking about from going from here to the pie chest in both cases. I see your, yeah, I'm running too. So I see your hand, Lily. I'm gonna let people marinate on this question for a little longer before we answer it. But which of these 2 races, again, the only difference in the conditions is that here the first 3 people to get there get a $10 gift card, and here there's 15 for first place, 10 for second, and 5 for third. Does race 1 or race 2 have the longer list of possible winners? And why? Or are they the same? All right, I see your hand, Cece.
I don't know what I want to answer it though.
Okay, so we have an answer, we're sitting on it.
I'm doing the maybe call me thing.
Call me maybe. Hey, I just met you and this is crazy.
But here's the answer.
Call me maybe. Yes, Taylor.
I would probably say race 1 because the first 3 people are completely equal. They're all 3 winners. Versus the 1 winner. The 1 winner that gets the $15.
Well, but so I hear what you're saying, but these are all the winners. In other words, it's like at the Olympics, we've got gold, silver, and bronze.
But you're not really the winner if you don't get the gold.
Well, you're still a prize winner. You're a prize winner. So let me this is a good clarification. Does race 1 or race 2 have a longer list of total possible prize winners? Okay, I'm seeing a stronger hand. I'm coming back to you, Cece. Yes, CC.
Oh, well, I don't think so because 3 people can win there and 3 people can win there. That's it.
So they're gonna have the same.
Oh,
The list will be the same because it's 3 winners either way. I saw and I know. I see your hands, Lily, but I have a feeling I'm gonna get a definitive answer, so I'm giving people the chance to think about it. Yes, Mira.
I think race 2 because there's different amount of money for like each place, and so like there's different amounts that you can win.
Ah,
But in the end,
So-
it's the same amount of money because you got the $30.
it is the same amount of money. But let's see, can we come up with can you come up with like a concrete example with names of people in the room that would illustrate your point? So I see where you're going with it. Can you come up with a concrete illustration? Yes, Taylor.
I'm just saying, what if we all just run in one straight line? Then we'd
So
all
it's a
get
tie?
Yeah, we'd all get first place.
How would we all fit through the door of the pie
Yeah.
chest at once, though? Like that's not like if we line all of us up.
All
that's
we
gotta
would
be
all
like one
have
of those
all we would
major
have to
sliding
do
doors.
is all matter phase shift so that all of our mass can pass through the mass of the walls and the windows. That's
I don't
all.
think we can do that. That sounds.
All we have to do is synchronize about a quadrillion atoms
Synchronized.
into a phase shift so that's all we have to
I
do.
don't think that's
This is
what
why
we have
walking
to
through walls will be totally possible
Also,
at some point.
What is the
Wait,
what's the
that's-
question
wait,
again?
I'm so excited for
Like
that.
in our lifetime?
Probably not. Probably
Right.
not in our lifetime.
I mean, I don't know. Technology has advanced so quickly in my lifetime that possibly
I mean, we
by
got
the
the-
time you're retired,
We got the
I
COVID
mean,
vaccine in like
Yeah.
a year.
Maybe
I've
they
also
can
got the
figure out
chance
how
that
to
they
make
find a
live
way to
longer.
extend our
Yeah.
lives further. The moment that our lives are about to end, then we suddenly become like our life expectancy has increased, and then they keep on doing that right when you're about to die, and then you're technically
all we have to
immortal.
figure out how to do is how to upload our consciousness
Exactly.
digitally.
I think let's do that.
That's all we have to
It
do.
sounds like creepy from Star
Guess what?
Wars.
That's
what
I'm
bad
not
guys
gonna
do.
do that.
Well, what
Like,
if
Okay.
everyone
it's a
else does
virus?
that. I will just.
Yeah, we'll have to be really careful with the phase shifting though, because what if I accidentally
What if they
phase
get
shift
stuck?
with the floor or the ground and I just fall into the
Like
magma
in
at the center of the
Minecraft.
earth?
So scary.
Like in Minecraft,
Wait,
Then
wait,
you'd be in a
Earth.
completely different
Wait,
type of
wait,
Yes.
wait,
society,
wait,
where
Yeah.
mass
wait,
amount of
actually, you'll
people.
be the first person. You'll be like the person who's gone like the deepest ever to go to like in Earth. 'Cause, like,
Yes.
they've only
And
been-
as
they've
long
been
as
able to
I
dig
have,
very deep.
prior to doing that, I've uploaded all of my consciousness into some sort of like digital brain substitute, then even if biologically I perish by accidentally
Right.
phase shifting into the center of the earth, it
Doesn't
won't be a problem.
Wait,
Doesn't that mean that there's a new type of like attack, terrorist attack, where they just upload a virus to everybody's minds? Like,
Yes.
everybody's software all at once.
Yes. Yeah, no,
That would be
in
terrifying.
yes.
The amount of control that people would have, people who are able to program to do stuff like that,
yeah, no, it's
it would be insane.
yeah. Yeah, no, it would in fact most of our technological advances have exacerbated as many problems as they've solved. And that is
Yeah.
only likely to continue. Yes, Cece.
So if we drained all the magma out from inside the Earth, would it still be really, really hot?
Yes.
I feel like it
Well,
It'll take time.
Do you
to
mean
cool.
like drained it onto the surface of the planet so the planet were hollow?
Shot off in space. You get a little straw and space goes. And
Well,
everything
right.
goes in
Well,
it
what's
says
happening
we
right
wouldn't
now
be
is
able
that our
to-
planet is slowly cooling. In fact, because of entropy, all matter in the universe is in a process of cooling.
The
But we
eventual
can't-
peak of the
So it
universe.
would just so if the magma at the center of our Earth didn't have the insulating mantle, then that would just increase the rate of cooling of the magma. But, so
But
But also, it doesn't matter for us because it's all fine. It's not gonna happen.
But
you
if
know,
we
this
got
we're
rid of-
talking about processes that take millions or billions of
But
years.
if we got rid of the magma, would more magma come to replace it because more rock would melt because it was super, super hot?
No, because fundamentally what you're talking about is changing the mass of the planet. You're removing a substantial volume
But I mean,
of
if you
mass,
got-
and so what would happen is the gravity of the planet would cause like the
If it
mantle
did-
and the surface to collapse.
if we pretended
and the-
like it didn't collapse, that would still be really, really hot.
No, because because the vacuum isn't, I mean, I suppose if it were filled with air, that air would be hot because of the pressure. But it probably wouldn't create more magma. We'd have to do some calculations. Yes, Lily?
How did we get from pie chest to like Armageddon? I'm very confused.
I don't remember what the steps were. We'll have to play back the tape. All right, so coming back to the question that I asked you, Mira, can you give like an example that illustrates your suggestion, that shows that there are more possibilities here than here?
Like, I mean, one person could win every single place.
Yeah. So let's go ahead. Let's say, I'm just going to pick you and your neighbors, Mira. So, Mira, Lily, and Cece get to the pie chest first. And they each get $10, even if they get there in this order. In other words, this is not a different outcome from this one in this case. And this is not a different outcome. These are under this circumstance, these outcomes are identical. How many different ways, try this on your paper right now. See how many different ways you can set up the podium for this. So we've got first, second, third. And here it does make a difference. This
How many
is,
people are there?
yep.
Oh, oops. That's the wrong thing.
But see if you can actually create them. I'm hearing some, what sound like some spot on guesses.
Oh,
But see if you can actually do the list.
Oh, wait. Yeah. Are we doing it when there's 3 people?
Yep,
But there's different people other than 3, right?
there are. So here we're just illustrating the difference between this instance and this instance. Then to calculate how long each list is in total, including everyone that's in the room, that is a separate consideration.
Wait, so what am I supposed to be answering? So I did it where there was 9 people in the room. And then there's 3 different things it could be.
We'll get there.
Okay, so should I
So
do
we'll
where
get
there's
there.
3 people in the room and there's 3 different things it should be?
So right now we're just illustrating the difference between, we're illustrating why the list for race 2 is longer than the list for race 1 with just this example. Let's say these are the first 3 people to get to the pie chest. That's only one item on the list in this case. And I heard a few people say it. That's 6 items on the list. In this case, did anybody come up with an outcome that I didn't list on the board here?
I'm not really sure what the question is. So maybe, because I think I answered it.
Okay, so give me then a list of, again, just considering this, in this race, this is just one outcome. These 3 people of the 9 show up first. But in this case, these 3 people can show up first, but the order that they show up in is actually a separate outcome. So this is one possible outcome here. I've got 6 options on the list here. So you're saying so then my question is, did I miss any? Are there any other ways for you, Lily, and Mira to show up at the pie chest first?
Nope.
Yeah. This is comprehensive. so we can see, and again, and this is just with 3 people out of the 9 of us. We can see this list is going to be much longer than this list. And what it comes down to is order does not matter. And here, order does matter. So now let's see exactly how long each of these lists is. There are 9 of us in the room right now. When order doesn't matter, we're calculating the number of combinations. And when order does matter, we're calculating the number of permutations. Your calculator can do this. It has a function big C for combinations. And it has a function big P for permutations. In this case, N is the total number of participants. So for these 2 hypothetical races, what is our N?
3.
9.
Well, 9.
Yes. So 9 is our total number of participants because there are 9 of us in the class. But 3 is the total number of people who can win something.
I got you last.
Yes. And so it's the same here. Okay, on your calculator, you're going to do 9 NCR 3, or depending on your calculator, you might be able to select NCR and then type over the blank spot for the N and the R. So it depends on your calculator. But let's go ahead and do that. So if you've got one of these, if you've got a calculator like this that doesn't have as much flexibility with typing over, you can go to your math menu and then you can go to the probability menu. And the 3rd down on the list is NCR. But I've got to type 9 first. So I go 9, math menu, probability menu, 3 for NCR, put 3, and then hit enter. So let me see. Yeah.
I also found the permutations by multiplying. The first part is there would be 9 options because 9 people get first place times 8 because of 8 options get second place and 7 because of 7 people who get third place.
Yes.
Not the same answer.
Indeed. So there are many ways. So we got our C's and our P's. Yes, very good. And then you delete, so do it again.
Oh.
So we go to, let's see, so exit out of there. Now go to your math menu, and then your probability menu. There's the C. Yes. And in this case, with a calculator like this, then what you want to do is you want to first do the 9, then do the NCR, and then do the 3. And you got your NPR. And does your calculator do this?
Which one?
Well, any of them. Do any of your calculators do combinations or permutations?
I think this one might.
Okay. But is it out of battery?
No.
No?
I've just never been able to get it to work properly. Like
Okay.
I said, it's Street Fighter combos.
Okay.
They're more confusing.
So if you go to your math menu and then go to probability and then NCR, which is 3. Okay, and it'll let me write. So you can just do 9 and 3. And then you can do the same thing with NPR. All right, so how many combinations of winners of this race do we get?
84.
And how many permutations of this race do we get?
504.
So this is a big difference between combinations and permutations. And so when you see questions that involve needing to use combinations and permutations, this is how they work, this is how they're different, and this is where they are on the calculator. Do any of you have questions about combinations or permutations? No. All right. So moving on from that, so let's say I have a bag of marbles. Let's say that I ask you the probability that I just reach my hand in. Now here, this bag is clear the way that I have drawn it on the board. But now we imagine that it is opaque, and I ask the question, what's the probability that I reach in and pull out a red one? Lily, I will let you go ahead and answer this one. Thank you.
0.3. Is that right?
That's right. So because 3 of the 10 marbles are red, I have a 0.3 or a 3/10 or a 30% chance of pulling a red one out of the bag. Yes, Cece.
So how do you want us to answer? Do you want us to do it with a fraction or a decimal or percent? Or do you want to be simplified? Does it matter?
I'm pretty agnostic towards it, although if it's a fraction, the fraction should be reduced.
Okay.
But,
So why should it not be reduced
That
though?
was always pain. Digital tests, they either reduced the fractions or they didn't.
yeah.
And if they didn't and you reduced the fraction, you got the question wrong.
Generally speaking, it's a good math grammar to reduce a fraction.
Well, my
Gen-
teacher said that we're not supposed to reduce the fraction for
Why?
probability. I don't know, he just said not to. It was weird. And then somebody said told us to actually. And then, so I don't know. I'm just putting like a rule about that.
I mean, generally speaking, I mean, there may be a specific reason, like in other words, like the teacher wants to be able to see your thought process,
Yeah.
which is easier to see if you don't reduce the fraction. But generally speaking, in terms of good math grammar, it's better to reduce fractions, almost always. All right, how about if I say,
Which ones are striped? Are those the wavy ones?
yep, yes, Gio?
7 out of 10, so like 7%.
Yeah. So this is 7 out of 10 or 0.7. or 70%. I think you can also write this as 3 to 7, and you can write this as 7 to 3 actually, although that's a pretty archaic way of doing it. But if you like experimenting with ways of showing proportions, that's another way to do it.
My favorite task.
How about if I ask, what is the proportion of blue, oops, if I spell the word and correctly. And striped. Yes, Marlon.
Oh, sorry.
So, because
Well,
I'm, so,
sorry,
yeah. This is a very good illustration though. This
20%?
is, this is a very good, yeah, 20%. And we can look here and we can see that there are only 2 marbles that are both blue and striped. So this is going to be 2 out of 10, or 1/5. But now let's think about, let's say that we have a slightly more complicated situation where we can't see all of the elements that are, let's say that I had 500 marbles in the bag or something like that, and we need to turn this into like from a simple counting exercise into something that's a little bit more formulaic. How would we be able to write an equation that would help us to algebraically calculate this probability if we know and again, these kinds of things are always such a stretch. But how can we relate the probability of maybe this question doesn't even make sense in this case. Let's move on to your question, to where you were going, Merlin. Let's say that we want to answer, that we pull out a marble that's blue or striped. What percentage is that? Yes, Lily.
That is, would that be, oh, sorry, wait, I need a second.
You already had this one, Merlin.
Yeah, well, it's no fun if I.
So what do you say, Lily?
7 out of 10, right? Because it can't be blue and striped, it was blue or striped.
Well, but these ones count for
Oh.
this is both blue, this particular marble is both blue and striped. So this actually fits both of the criteria.
Okay, then 8 out of 10, right? Wait, there's one not striped one that's not blue, so 9 out of 10.
So that, yes, which is the 90%, yeah, so this one is 9 out of 10, so this is 90%. But I'll ask the question for this one. The percentage of that are blue, there are 4. So this is 4 out of 10. The percentage that are striped are 7. So if we add these together, then somehow we would end up with 11 out of 10 or 110%. Which doesn't even make sense. So how can we do, in this case, how can we do a formula that accounts for this? Did you have an answer to that question, Cece?
I forgot what it was.
Okay. Yes, Lily.
It's the number of blue marbles over the number of total marbles, plus the number of striped marbles over the number of total marbles, minus the number of blue and striped marbles that are both
Yeah.
over the number of total marbles.
So it's the blue ones and the striped ones minus the probability of the blue and striped ones.
Because we counted it twice.
That's right.
Counting.
So this prevents us from double counting. So this gives us 4 out of 10 plus 7 out of 10 minus 2 out of 10, which gives us the 9 out of 10 or 90% that you and Merlin correctly identified earlier. I'm heading off of the screen here. So a lot of this chapter is just working with these kinds of formulas and just calculating the probability of pulling like a particular color or pattern or hitting a particular area on a dartboard. The one other thing that this chapter relies on a lot that we are going to need tomorrow is we need to know what the structure of a standard deck of cards is. So how many suits are there in a standard deck of cards?
4.
Yes, I'm seeing 4. All right, go ahead and shout them out.
Cards,
Spades.
diamonds, gems. And the clovers thing. Yeah, what are those?
Clubs.
And then there's 13, I think, of each of it.
I don't get why those are called clubs and not just like Pokemon shrubs.
They
Is
look
that
Because
really
they radically predate Pokemon.
They always. I
Why
can't
not,
look
like,
at those
plant
without
or
thinking of the
clover?
trees
Yeah,
that you
like-
can't bypass. The little tiny, like sticks of a tree that you can't bypass without using cut.
Why not? Why don't they just call it clover?
Yeah, exactly. It looks
Yeah,
like a clover.
Or at
Well,
least
I'm running
make
out
the
of space
club
here.
look like a club.
I've always
I
thought
will
it
tell
was-
you this, when I was living in Spain, the playing cards over there, the clubs do actually look like a full-on caveman club. It's like
Wow.
the big sort of like knotted wooden. So the clubs really looked like clubs. So I think it's become, modern decks of cards have become a lot more stylized.
Do spades look like actual spheres?
It looked like a balloon
Yes.
bunch.
And this was
Well,
actually
spades
this
itself.
was actually like a sort of like a gilded, bejeweled goblet that was filled with like golden coins and jewels
Oh, wow,
and stuff.
yeah.
So yeah, like it was much more elaborately.
I mean, I think
Why
I
would
have
they
Illustrated.
elaborate?
I mean, I think
Because
I
Are you
have
talking about the
heard,
Spanish playing cards?
Yes.
Oh, those are completely different from these. Then.
I think this. Well, also I think the suits are different. Like you remove a card.
Well, but the combinations. In other words, there were still 4 suits. They were still related to like
And then you
power, money, industry, and love.
It's
Wait,
no,
wait,
it,
that's
it,
what they mean?
it was gold. They're gold swords, clubs, and a goblet. That's what the Spanish playing cards are.
Yep.
The
Gold,
gold,
So
sword,
seven-
oro.
Wait, what did they?
Yeah, oro is gold.
And then-
Copa is
What
like
are
goblets.
and then there's the
Basto,
basto.
Basto, which is like this like horn club thing.
Yeah, there's a.
I
it
can't
was-
remember.
I just called it the troll club.
Yeah, and then
So
there
this
was like
is so this
sword.
so the tradition has many manifestations. I don't know if any of you have ever played Hanafuda or the flower game from Japan, but that has 12 suits of 4 face values each. What a lot of these card games are based on, what do we experience all the time that it comes in 13 subdivisions of 4 categories.
The year?
Yeah.
The Ace of
Four-
Spades is
four-
my favorite card.
4 seasons.
I'm done.
You and Lemmy. You like Motorhead?
What?
Ace of Spades?
Oh no, I like it because it's a big gun.
Oh, okay. Well, it's a great track. I don't know if any of you like late 70s, early 80s hard rock, metal, Motorhead, Lemmy, anyone? No, okay, I'm talking to myself. So yeah, so these are like the 4 seasons and the 13 weeks that are in each season. So there's definitely a tradition of card games around the world that are in some way representative of the 4 seasons.
Wait, then why don't they make it like
Flower and then
snowflake,
Red leaf.
leaf,
and
I don't
grass
know,
or
grass.
Snowflake,
happy
flower,
Red leaf.
Leading up
and
Well, because then this also becomes representative then not just the seasons of the year, but the seasons of life, or like the major experiences or goals of life. You know, interactions,
It's been outdated.
power,
Love.
wealth, industry, love. So it becomes, at this point again, it's extremely stylized. And when we're just playing it or looking at it, we're not thinking about the seasons of the year or the seasons of our lives.
And the seasons of your lives are like being a baby, child, teenager, everything
Being
that's being
adult,
an adult,
adult.
being old.
Yeah.
Old adult. And there's medium adults.
But-
I don't know. There's a lot of adults.
Nevertheless, it's one of the things that's just interesting to think about, and why, in part, card games, you know, there's something sort of like archetypal about it, that it ends up being, games of this kind end up being very popular worldwide. But, all this to say, this means then in a standard deck of playing cards, or a standard Western deck of playing cards, how many cards are there in it total? If there were,
Pick up.
yes. So it means there's a total of 52 cards, because there's 13 each of the 4 suits. So there's quite a few questions that relate to pulling a card from a deck of playing cards. Collectively, what are these 3 referred to as?
Face cards.
Yeah, these are face cards.
What's the A? Oh, yeah.
Ace. Wait, is ace not a face card?
Ace is not a face
What
card.
is ace then? Is ace a special card?
Yeah, ace is the top, the pinnacle, the numero uno.
Top banana!
That's right, the top banana, the big kahuna. So that's why Dr. Dre says, you know, they're trying to be the king, but the ace is back. So that's just a little shade that he's casting on some of his, you know, rap critics and competitors. Yes, CC.
Oh yeah. What do the different colors mean? Does that have something to do with the seasons?
I think putting it down to just, one of the things is that if we just have 2 colors in the deck,
It makes it organized.
it's much, well, it makes organizing it fast, but also it's much cheaper to print. So again, I think that playing cards, as the designs have become much more simplified and stylized, and then only having 2 ink colors means that the cards are still distinguishable from one another, but they're much cheaper to print. So these like really elaborate sort of prior decks of playing cards that I think some of them probably originally were just like made by hand, it has become very stylized like this, so that it's very easy to print and distribute. Yes, CC.
At the sprinkle party, maybe please look at pictures of old cards.
Yeah, we can look up some. Yeah. If you wanna spend some time looking up,
Can we just do that on our own time?
That is almost as
yeah, you can do
random as
that, but
the
you
smell
can bring
of
in you can bring in your favorite,
I don't
and
know.
I will try to.
lost all mine. I didn't put it back in
Yeah,
the
we know
container.
you have to put yours.
I just put it back in the
That
box
sounds
and then it ended up somewhere. I mean, for an hour, it's a neat little pile on the table, and then, another hour, and they're on the floor everywhere. And
Yeah.
I almost picked them up.
And I will bring in, I will make a note to myself to make sure to put that in my bag tonight, but I'll also bring in my deck of Hanafuda cards so that you can see a similar deck of cards, but that is done in a very different style.
The only card game of luck that I'm good at is Pepsi.
What?
What is
I
Pepsi?
don't know
You
that,
have
well,
to- You have to get all 10 cards in order in a row, and then the kings and queens, they don't matter. Jacks are wild. They can
Gotcha.
do whatever number they want.
okay,
You
well,
lay-
we'll
you
see
lay
if we
10.
have some time for some additional games of chance tomorrow.
There's
I
too
played
many
Rummy.
people